Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have m to the power of 4 equals 4. So what I'm first going to do is I'm going to subtract 4 on both sides. So now we have m to the power of 4 minus 4 equals 0. So now what I'm going to do is I'm going to change m to the power of 4 to m squared to the power of 2. Because remember, if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So what I did was I changed m to the power of 4 into the form a to the power of m to the power of n. And we're going to subtract this with, I'm going to change 4 to 2 squared. And this is equal to 0. Now, if we have something in the form a squared minus b squared, this is actually equal to a plus b times a minus b. So in this case, a squared, well, a would be m squared, and b, this would be 2. So if we plug these into this form, we would get m squared plus 2 times m squared minus 2. And this is equal to 0. And now we have two equations. We have m squared minus 2 equals 0. And we have m squared plus 2 equals 0. So let's first start with m squared minus 2 equals 0. So I'm going to write that right here. So what I'm first going to do is I'm going to add 2 on both sides. So we get m squared is equal to 2. So now if I take the square root on both sides, I get m is equal to positive or negative 2. So these are two solutions. Now let's go ahead and do m squared plus 2. So if I subtract by 2 on both sides, I get m squared equals negative 2. Now if I take the square root on both sides, I get m is equal to the square root of negative 2. Well, the square root of negative 2, this is the same thing as the square root of 2 times the square root of negative 1. And the square root of negative 1, this is equal to I. So this would be positive or negative square root of 2 I. So m is also equal to this. So these are the 4 solutions to this equation. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x to the power of 5 equals 100. Now, what I'm first going to do is I'm going to take the power of 5 on both sides. So we have x to the power of x to the power of 5 to the power of 5. And this is equal to 100. Now, if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, right? However, for multiplication, order doesn't matter, meaning we could actually switch the places of these two, meaning this would also equal to a to the power of n to the power of m. So a to the power of m to the power of n and a to the power of n to the power of m, these two are the same things. So for this, I'm actually going to switch the places of x to the power of 5 and 5, because think of x to the power of 5 as m in this case, and think of 5 as n in this case. So by doing that, we would get x to the power of 5 to the power of x to the power of 5. This is equal to, and remember, when we're taking the power of 5 on both sides, we got to do it to both sides. So this would be 100 to the power of 5. Now for 100 is actually equal to 10 squared. So we have 10 squared to the power of 5. And remember this property, a to the power of m to the power of n, this is equal to a to the power of m times n, meaning 10 to the power of 2 to the power of 5. This would equal 10 to the power of 2 times 5, which is 10. So we have x to the power of 5 to the power of x to the power of 5 equals 10 to the power of 10. Now, if a to the power of a equals b to the power of b, then this means that a is equal to b. So if x to the power of 5 is to the power of x to the power of 5 equals 10 to the power of 10, then this means that x to the power of 5 is equal to 10. Now we want to cancel out this fifth power, so now I'm going to take the root of 5 on both sides, and these two cancel out, and I would be left with x is equal to the fifth root of 10. And this can also be written as 10 to the power of 1 over 5. So this would be our answer.